This is a donut. This donut is the future of humanity's energy. This $18 million, 23,000-ton donut is being built by the European Union, India, Japan, China, Russia, South Korea and the United States to be a next-generation nuclear fusion reactor. What's that, you say? Basically, what these countries are trying to do is make an artificial star, 10 times hotter than the centre of our Sun. By holding plasma in the donut at 150 million degrees with magnetic fields, nuclear fusion can start. This special donut that can survive these temperatures is called a tokamak. This is no mean feat. The most powerful nuclear reactor to come before it, the Joint European Torus, or JET for short, produced 16 megawatts of electrical power when it was powered by 24 megawatts, meaning it consumed more power than it produced. The fusion reactor currently being built is the International Thermonuclear Experimental Reactor, or ITER for short, and this will produce 500 megawatts of power after consuming 50 megawatts, meaning it produces 10 times the amount of power it consumes. But how does this work? Well, remember this dude? He made an equation called E equals mc squared, the most famous equation ever, which basically says that you can turn a small amount of matter into a tremendous amount of energy. The reaction works like this, but all you really need to know is that the missing mass is being turned into energy as light and heat. But you say, what's the catch? We all know how dangerous nuclear fission can be when improperly used, so what's the difference with fusion? There are a few things that make fusion in ITER safer. The main byproduct of the fusion process is helium, which is a harmless gas. Also, nuclear fusion requires carefully controlled conditions, and without these, the plasma cools and the reaction stops. The only radioactive waste from ITER will be the reactor core itself, with a relatively short half-life. If we can make nuclear fusion safe and viable, it will be the energy source for the foreseeable future, without greenhouse gases.